Hi, welcome to your first flipped classroom video, AB video 1.2a. So I'm going to give you a couple of examples of graphs, and we're just going to do this graphically, which is just observing the graph. So if you look at this graph, which is a line, a solid line, and there happens to be a point on that line, 2, 3. So you can see there is a point 2, 3, which means f of 2 does equal 3. Okay? Now, however, we're not really interested in what happens at 2. We're interested as x approaches 2. So we're going to look from the left side. If you're on the left side of 2 and you were a little bug crawling along this curve and you were approaching x equals 2 from the left side of x equals 2, you'd notice that you are indeed approaching a height of 3. Okay, getting closer and closer to a height of 3. Same thing happens as I approach 2 from the right side on this function. The limit as x approaches 2 from the right is also equal to 3. And as you can see, let me get this into your screen of your viewing screen. As you can see, we represent approaches 2 from the left with a minus sign, and we represent approaches 2 from the right with a plus sign. So the little plus sign kind of in the exponent location. Now, because the limit as x approaches 2 from the left of f of x and the limit as x approaches 2 from the right of x are both equal to 3, we are able to conclude that what we call the two-sided limit, notice there's no plus or minus up here, that the two-sided limit is of f of x as x approaches 2 is equal to 3 because both of these are equal to 3. Okay? Okay, and that's called the two-sided limit. The way we read this is the limit as x approaches 2 of f of x. The limit as x approaches 2. We're not talking at 2, but we are talking very, very close to. So close to 2 is not 1, is not 1.5. We're talking 1.999, 2.001. Okay, so here's an example of a graph. I'm calling this graph g of x. G of 2, as you can see, there is no point at 2, 3. So that simply does not exist. Okay, it is undefined or does not exist. The limit as x approaches 2 from the left, and I have color-coded everything here. So you'll notice this is in green. So if I'm approaching 2 from the left side of 2, you'll notice I am approaching a height of 3. I'm not getting to 3, but I am approaching a height of 3. The limit as x approaches 2 from the right, as you can see in blue, as I'm approaching from the right side of 2, this is 2 here right below, so obviously this is the left side of 2, which is the green. This is the right side of 2, which is the blue. You can see again I'm approaching a height of 3. So what we say is because both the left-sided limit and the right-sided limit each equal the same real number, we are able to say that the two-sided limit, which is with no symbol here at all, as x approaches 2 of g of x is 3, for the simple reason that both of these are 3. Now, visually or graphically, it's because as the green bug gets closer and closer to x equals 2, and as the blue bug gets closer and closer to x equals 2, both of them are approaching a height of 3. They're almost touching, but not quite touching. So here's another example. And here we have a very similar situation, but this time there's a disconnect. So this would come from a piecewise function or a piece function. So we have one graph on the left side of 2 and a completely different graph on the right side of 2. So again, the questions will often be, what is h of 2? So this is the function h of x. So h of 2, as you can see, there is no filled in dot here, so there's no h of 2 here, but there is an h of 2 right here. And h of 2, that's a filled in dot, h of 2 is negative 4. The limit as x approaches 2 from the left. If the bug is on the graph on the left side of 2, which would mean on this piece here, as that bug approaches 2 from the left side and gets closer and closer to x equals 2, it is indeed getting closer and closer to x equals 3. to y equals 3, I'm sorry. Same thing on the right, different thing on the right side. On the right side of x equals 2, I'm now on this piece. As we approach 2 from the right, you can see that we're getting closer and closer to the height, -4. So the limit as x approaches 2 from the right. Sorry, let me bring this within your view. And okay. The limit as x approaches 2 from the right, as you can see, is -4. Now here what happens, because these two numbers do not equal each other, okay, from the left is equal to 3 and from the right at 2 is equal to -4, we say that the two-sided limit does not exist. And again, if you're looking at it graphically, you can see that these two bugs, as each approaches 2, one from the left, one from the right, they are nowhere near at the same height. They are not almost touching at all. Okay, so here's another example. So here's a graph. It's a piecewise function. There is an empty dot there, but there is a filled-in dot right here at 2, 1. So w of 2 does exist. It's equal to 1. The limit as x approaches 2 from the left, as you can see, is approaching a height of 3. The limit as x approaches 2 from the right is also approaching a height of 3, and therefore the two-sided limit is 3. Notation is extremely important. You will lose points for the wrong notation. Whether you write the function name f of x or you actually write the expression for the function, what the function is equal to, but you have to put something there. You cannot have the limit as x approaches 2 of nothing. And that's the key thing here, is that you have to have something here. The limit of which function is the question, okay? And same thing over here. You could not say the limit as x approaches -1 equals -2. It has to be of something. So once again, there has to be a function name or an actual function in that location. Now, the theorem that we've already been using says that the limit as x approaches a number a of a function f of x equals a real number, capital L, if and only if, and if you remember that from geometry, that means I can switch the if and then parts. So it means that if the two-sided limit equals L, that means that the two one-sided limits, the limit from the left and the limit from the right of f of x, both equal that same L. Vice versa, if both of these one-sided limits are both equal to L, the two-sided limit is equal to L. All right, so from the textbook, these are graphical questions. They're giving you the graph. They're giving you the equation of the function up here as well. They could have just said this is f of x. What's the limit as x approaches 1 of f of x? But you are doing this graphically, which means you're looking at the picture. The question is, what is the limit as x approaches 1 of x squared plus 3? Now remember, this is a two-sided limit, so you have to make sure that from the left and from the right at x equals 1, that they equal the same thing. So you can see here, sorry about that, telephone rang. Okay, so the limit as x approaches 1 from the left, there is no dot there, let me get rid of that dot. Okay, let me be here. So if you follow this little plus sign here, the limit as x approaches 1 from the left is approaching that height of 4. Oh my God. Keep the color scheme. Don't show this message again. And the limit as x approaches 1 from the right is also equal to 5, hence the two-sided, is equal to 4. I'm sorry, 1, 2, 3, 4. In both cases, they're approaching that height of 4. So since the two one-sided limits are equal 4, that's why we say that that two-sided limit is equal to 4. Okay, moving to number 18. They want you to find the limit as x approaches 1 of f of x, and here's our graph. Here's the equation, but don't worry about that for now. We're doing it graphically. Again, limit as x approaches 1 from the left is approaching a height of 4. Limit as x approaches 1 from the right is also approaching a height of 4. Thank you. Sorry about that. So the limit as x approaches 1 from the left is equal to 4. The limit as x approaches 1 from the right is equal to 4. You will notice there is a point here, but we don't care about that point because that's what's happening at x equals 1. We're not interested as to what happens at x equals 1, only near x equals 1. So again, the answer will be 4, and the reason is because the two one-sided limits are both equal to 4. Actually, I'm going to keep this. Okay, I think I have one more, number 20. So here, as you can see from the graph, this is the first example where we have a vertical asymptote right here. And they're asking for the limit as x approaches 5, and sure enough, that's where the vertical asymptote is. So again, if you're looking at the limit as x approaches 5 from the left side, here's 5, here's the left side of 5, here's 5, here's the right side of 5. So if you're on the graph on the left side of 5 and you're approaching x equals 5 from the left, you'll notice that where you're heading is down to negative infinity. The limit as x approaches 5 from the right, you'll notice it's going up towards positive infinity. Now, since neither one of those actually equals a real number, we could say that those two limits do not exist, okay? So either way, you can say that from the left, it equals negative infinity. Remember, it was pointing down on the left side of 5, or from the right, pointing up, and therefore going up to infinity. Now, yes, it's true that they both don't exist because they don't equal a particular real number. However, these are much more descriptive, visually descriptive answers. So always give the more descriptive answer. All right, obviously these two bugs, this bug over here on the left and this bug over here on the right, are not anywhere near each other. And of course, yes, you can see algebraically, one goes to negative infinity, one goes to infinity. So we say that the two-sided limit simply does not exist. Okay. Here's number 26 on page from section 1.2. So they give you this graph and they're asking you what's f of negative 2. Now you'll notice there's a vertical asymptote there, so it doesn't exist. What is the limit as x approaches negative 2 from both sides? You'll notice that the limit as x approaches negative 2 from the left is negative infinity, from the right is positive infinity, so that would also not exist. Okay? What is f of 0? There is an actual point here, 0, 4, so that will be 4. D, what is the limit as x approaches 0? Again, from both sides, you'll notice from the left, as you get close to x equals 0, you're at a height of a half, it looks like. But as you approach x equals 0 from the right side, you're at a height of 4, so that two-sided limit would not exist. F of 2, there is no point with a 2, so that would not exist. Undefined or does not exist. They then ask you for the limit as x approaches 2 from both sides. So going back up to the picture, the limit as x approaches 2 from the left is a half, it looks like. Also from the right, it is a height of 1/2. So that answer would be 1/2, which is, I hope, what I put, and it is. Okay, the next one is f of 4. F of 4, you'll notice there is an actual point here, which is the point 4, 2. So f of 4 will equal 2. And finally, they want the two-sided limit as x approaches 4. Let me just pull this over here for you to see it. The implication here is that there is a vertical asymptote right here. I don't know why they didn't draw it, but you can see that this is going up forever, this is going up forever. There's no way it could turn around and come back down, because that would put 2 points on the same vertical line, and this would no longer be a function, and they're calling it the function f of x. So in that there's a vertical asymptote, you'll notice that the limit as x approaches 4 from the left is infinity, which doesn't exist. Limit as x approaches 4 from the right is infinity, which doesn't exist. So there are different ways to write this. One answer, of course, is that it doesn't exist, but they are both going up to infinity. One could say that it equals infinity. And for the last question, number 28, use the graph of f to identify the values of c for which the limit as x approaches c of f of x exists. Okay, so where does it exist? So the question is easier. Where does it not exist? And it exists everywhere except for where it doesn't exist. So you'll notice here, although there's a break in the graph, we're not talking about breaks in the graph, we're just looking at limits. The limit as x approaches negative 4 from the left and from the right are approaching that same height of 2. So we have no problem at negative 4. But we do have a problem as x approaches negative 2. From the left, it's negative infinity, which means it doesn't exist. And same thing from the right, negative infinity doesn't exist. So we have a problem at negative 2. We also have a problem at 0 because the limit as x approaches 0 from the left is 0, but the limit as x approaches 0 from the right is 5. So far we have two places where it does not exist, which is -2 and 0, and you'll notice everywhere else there's no breaks or jumps of any kind, and all those limits are okay. The domain is all real numbers, by the way, because -4 is in the domain, x equals -2 is in the domain, x equals 0 is in the domain. But that has nothing to do with the question, really, because as it turns out, the two places where the limits don't exist are at -2 and at 0. So the limits exist for all C element from -infinity to -2, union -2 to 0, union 0 to infinity. We're assuming you know interval notation. You can use the word or the symbol U, which means union. And that is the end of your first video. And assuming this is now September, before the first day of class, I'll need you to read the online syllabus and print out and sign the form.